there. And again, welcome to the North Central Climate and Drought Outlook for May of 2024. Today, we're joined by Justin Gleason, who happens to be the state climatologist of Iowa, and he'll give the presentation, which will be followed by sort of a Q&A session. So if you have questions, please put them in, or comments, please put them into the question box there, and we'll either answer them as we go or answer them at the end. By the way, my name is Doug Cluck. I work for NOAA, the National Oceanic and Atmospheric Administration. I'm also joined by Dennis Toddy, who works for the USDA's Climate Hub in the Midwest. And I guess at that point, or at this point, Justin, why don't you go ahead and go live and take it away, and I'll shut up.
All right, great. Thanks, Doug, and thanks, Dennis, for also being on. Good day, everyone. As Doug mentioned, I'm the state climatologist of Iowa here at the Iowa Department of Agriculture and Land Stewardship. And the joke is they keep me as a trained meteorologist and climatologist in the basement of the Wallace Building at the Capitol Complex, and hence some distortion in my phone line. But let's get started. So, as I've said before in these presentations, and as my colleagues say each month, this is a regional and local collaboration of a lot of different people: state climatologists, my federal partners, the USDA climate hubs, Midwestern and High Plains regional climate centers, and the Drought Mitigation Center. I can't do my job without these regional and federal partners, so we have a great collaboration. In fact, next month, this webinar will be given by Dr. Aaron Wilson, the state climatologist of Ohio at The Ohio State University. Here's information on access to future webinars, and then the recorded presentations from the past several years. And again, as Doug mentioned, questions at the end. So a presentation outline, recent condition. We'll look at temperature and precipitation ranks for the month of April, but also year to date. Then shorter term, 30-day temperature and precipitation, and of course drought, which has been a big story here in Iowa and other parts of the central region. Planting and growing progress, impacts and notable events, particularly severe weather, but also space weather, as you see in the picture on the right. This is aurora from very light, dense, light pollution Des Moines in my backyard with 100-year-old trees. Then we'll look at outlooks. We'll talk about the rapid shift from the strong El Nino that gave us a very warm winter into the potential for La Niña in the summertime. Then short-term outlooks, and talk a little bit about what we see in the summer outlooks. All right, so for recent conditions, we'll get into it here. This is the statewide average temperature rank for April, and these go back to 1895. And what you're seeing here are temperature ranks. So the higher that number, the warmer the month it is for the given state. So the redder the reds, the warmer it has been for a particular state. So what you can see with the broad scale pink to red colors across the United States, unseasonably warm across the region, particularly south and east in the eastern Corn Belt and Missouri as well. We draw our attention to Ohio, the 6th warmest on record, going back again to 1895. So this is a reflection of very warm conditions that we've had 11 consecutive months globally. Now, if you decouple the daytime high, what we call the maximum temperature, and the overnight low, or the minimum temperature, you also see the story here is that in the eastern part of the region, our temperatures, our overnight temperatures, have been particularly warm, in the top 10 warmest since 1895. Not so much on the daytime temperatures, a reflection of more cloud cover, more precipitation, but also that same interaction with cloud cover holding those those overnight low temperatures a tad bit warmer. So this has been a particular story that we've been following over the last several months as well. Now, if we look at season to date temperature departure rankings, and these are stations, longevity stations across the central region, this is ranking the season to date, so meteorological spring, March, April, and May. In the redder the red, you can see the numbers on the boxes there, that gives you an idea how warm this spring has been, and then a continuation of year-to-date temperatures, which would be a similar type map. But you can see in the eastern Corn Belt, getting over into Indiana, Ohio, top 5 warmest starts. And then we see top 5 warmest getting into Iowa and Missouri, and then a little cooler, top 10 in Minnesota. But again, this really drives home the point of how warm it's been through winter and spring. Now, shifting to precipitation, again, this goes back to 1895. The greener the greens on this map, the wetter the month of April has been for the states. Wherever you see those brown colors, which we don't see any in our region, that's drier or below normal. Broad scale wet conditions across the region, especially in the eastern Corn Belt, stretching from Illinois all the way over to Ohio, and then South Dakota and Minnesota, also wetter conditions. But overall, you're looking at the central region, wet conditions with the exception of Montana, which is in that near normal category. Now, if we break this down by county, this kind of gives us a more granular idea of where wet conditions have gone across the states. And you'll note that in Kansas and getting into southeastern Colorado, particularly dry conditions, perpetual dry conditions that stretch back months, several years, in fact. And then up into Montana and parts of western South Dakota. But then you have these wet bands across South Dakota into Minnesota, and then parts of Missouri, Iowa, stretching all the way over into Ohio. Very wet conditions that have delayed planting across much of the area, but have also supplied us with much needed soil moisture, particularly where we're most drought stricken, and that's in Iowa, where my domain is, but also across Wisconsin and other states. So the double-edged sword here, delayed planting, delayed field work, but we're also getting much needed moisture recharge, much rebounding in stream flows as well from very dry conditions that we've seen over parts of the region. Now, if we go back to the beginning of the year, so these maps are the same that we've just seen, but January through April, so year to date. Very warm start to the year with many states in the top 5 and close to the record highs in Ohio, Michigan, Wisconsin, and Minnesota. And as I mentioned, the 11th consecutive month of record warmth globally. So again, broad scale across the United States, but drilling down into our region, very warm start to the year. Precipitation-wise, it's good to see these green colors across the region. Wetter conditions for much of the Corn Belt, save for outside the Corn Belt, but North Dakota and Montana. And then the drought risk that we've built up over the last few years, you look at Iowa, 202 consecutive weeks of D1 moderate drought somewhere in the state. So the drought risk that we've built up with these drier than normal months and years for some locations has somewhat been alleviated by recent and short-term rainfalls and precipitation in general. And this has been alleviated, at least temporarily. We'll have to look at summer and the potential for a warmer summer, as well as vegetative demand increases along with atmospheric demand. But overall, if you're drawing up a game plan to help alleviate drought conditions, what we've seen over the last several weeks and months is just what we needed. If we look again at the county level, January through April, you're going to see a similar behavior in the polygons that I show up. Very wet conditions across the eastern Corn Belt into the central Corn Belt, and then drier pockets northwest and across Kansas, where we've seen very, very dry conditions, which has been reflected in the drought monitor, but also stream flows, which I'll show later. Now, going back to the short term, this is the last 30 days, a departure from normal temperature. So the warmer the colors you see, the warmer the temperatures. And now this is a departure from the 30-year climatology, the last full 3 decades, 1991 to 2020. So I'll draw a line there, kind of give us a demarcation of behavior that we're seeing. Very warm conditions, up to 6 degrees above average across the eastern Corn Belt, southeastern Missouri, up through Ohio and southern Michigan. And then we shift over northwest, near normal to slightly cooler conditions, up to 2 degrees cooler than average, getting into the Dakotas and then pockets of Montana. But overall, the warm signal exists and persists. And there's that cooler than average pocket in the western part of the domain. Percent of normal precipitation, again, over the last 30 days, which has been remarkable. The cooler the colors, getting into those purples, much above average, 150, 200, 300% of normal precipitation just over the last 30 days. And as we get into April, May, June, and July, depending on where you are in the region, the wettest months of the year. So when you're getting above average precipitation during the wettest months of the year, that's where you're starting to alleviate those longer term precipitation deficits. And as we talk with our colleagues across the region and at the U.S. Drought Monitor, when do you start taking those very long term deficits 3-4 years out and writing them off because you're never going to make them up, and then balancing those out with the short term improvements that we're making, 150 to 300% of normal precipitation? That's the balancing act that we have in the weekly process for the U.S. Drought Monitor. And that's why on the ground observations are so important to match up with the modeled and the remote sense things that we get. But overall, you look at the central part of the region, very wet conditions. Moving over in the eastern Corn Belt, Indiana into Ohio, we see some pretty stark departures, 25 to 50% of normal. And then you look in the western part of the domain, again, pockets of 50 to 75% of normal, even getting down into 25. But where we're getting precipitation, especially in Iowa, is where we need it, given long-term longevity drought. Now, if we look at the percent of normal precipitation going back 3 full years, the story here has been widespread precipitation departures on the order of 70 to 80% of normal. So when you're talking about 3 years of drought and you're in the 70, 75, 80% of normal, you're looking at some stations that have pretty remarkable precipitation deficits approaching a full year's worth in parts of Iowa, getting into Nebraska, and even down into Kansas. Now, this is a great product that we have that shows where these precipitation deficits exist on the 20-plus inch level or greater over the past 3 years. So wherever you see a red triangle there, that's where we have pretty stark reminders of how dry we've been across the region, particularly Iowa, eastern Nebraska, and down into Kansas. And again, this is a good graphical representation of drought concerns across the state. Now, what we look at various hydrological and meteorological indicators for drought and wetness. As of this time last year, this was the 0 to 200 centimeter. This goes down to 80 inches of soil moisture percentile. So for this time of year, how wet or dry we are. Think of 100 years, the second percentile would be the top 2 driest years. So that very dark red category versus the 98th percentile. So this time last year, we had a big bullseye of very dry conditions across Nebraska, Kansas, Missouri, and then even some pockets in the eastern Corn Belt. And then we're sandwiched in between wetter soil profiles north and south. Well, here we are this time. This is the same product, but for the present day. We've alleviated at least some of those deeper soil moisture deficits, especially in western Iowa, but also in eastern Iowa, as well as much of the Corn Belt. Where we do see those drier soils persisting are in Kansas, and you can see that remarkable bullseye there that matches well with other indicators. But we've seen a good rebound in soil moisture at the expense, as I mentioned, of field work and planting progress. But banking moisture now is very important if we do get warmer and drier stretches during the growing season. Another example of soil moisture, this is the Climate Prediction Center leaky bucket. So it's a land surface model that gives us another idea of what soil moisture is behaving like. Again, percentile basis on the top left here, actual percentiles. So if you're near normal, you're in that 30 to 70th percentile where you see white. And then when you get into those greener percentiles, that's where we've seen more rainfall, more precipitation, more infiltration. So the darkest greens there, you're at 95% near capacity, at least what the land surface model is showing. And then you get into parts of Illinois and Indiana, some slight departures, 20 to 30th percentile. Bottom right-hand corner here, these are the delta plots. So the difference between the end of April and the first half of May. So wherever you see greener colors, that's where we've seen an increase over the last 2 weeks, a very active storm track, western Iowa, and then in drier conditions, Illinois, Indiana, and then over into the Dakotas, Nebraska, and parts of Kansas. So what we want to see is a convergence of evidence of our hydrological and meteorological variables that show us we are at a given drought category or we're moving out of a given drought category when you see improvement on the drought monitor depiction. So if we look at the USDA NASS topsoil moisture, and these are issued every Monday afternoon, and this on the left gives you an idea of percent short to very short. The first number there within a state is the percent of short to very short, and then the number in the bracket below is the amount of increase or decrease that we've seen since the last week. So wherever you see a negative number there, that's where we've seen a decrease in the amount of percent short to very short. Again, the darker the color, that's where we've seen drier topsoil conditions. But overall, looking good across the Corn Belt. We've seen some improvement in these longer term topsoil moisture deficits. And then you look at the map on the right, this is percent adequate, so you want to see a plus sign there. You want to see a plus because that indicates you're increasing the amount of adequate soil moisture, and then you're also getting into the realm of surplus soil moisture as well, which I'm not showing. But you look at the lower 48, we're plus 4% over the last week, plus 6 in Iowa. Look at Illinois, plus 16, a good improvement in topsoil moisture, also at the expense of planting and field work, which I'll harp on as we move forward. If we look at subsoil moisture, again, the same setup, short to very short on the left, percent adequate on the right. We want to see negatives on the left, which we do generally see across the region, and we want to see positives on the right in those brackets, and that's where we see anywhere from plus 6 in North Dakota, plus 9 in Montana, all the way over to plus 1 in Indiana. Now, our friends in Ohio, we've actually seen a dip in percent adequate, and that was reflected on those precipitation deficit maps that I showed a few slides ago. So we take all of these hydrological, meteorological indicators for the drought monitoring process each week. This is the map that was issued this morning, and as a reminder, this is backdated to 8 a.m. Eastern Time on Tuesday, so any precipitation that falls after that time frame is not reflected in the current map. This is the, did I update this? Yes, I did update this. So what we've seen a good improvement, particularly in Iowa, where again, 202 weeks of consecutive drought somewhere in the state. Basically drought free across the eastern Corn Belt and improving conditions across the western Corn Belt. But overall, this is a much better map than what we saw last year at this time, where we had D3 and some D4 conditions, Nebraska, western Iowa, and even in South Dakota. So if we look at a 4-week change map, this gives us an idea of how much improvement or degradation that we've seen in drought categories. This is a class change map. So for example, a 1-class improvement would be, if you look at southern Iowa, D1 conditions upgraded to D0 conditions, abnormal dryness, or even removal of abnormal dryness. So broad scale across the central region, we've seen a 1 to 2 class improvement over the last month. Drought degradation in Kansas, again, where I showed those soil moisture deficits, but also precipitation deficits and positive temperature anomalies. Status quo, where you see white, basically no drought, or if there has been, no drought exists there. Wherever you see gray there, status quo, no improvement, no degradation, enough precipitation during the week to hold things steady on the map. Okay, now we're going to shift to growing season progress. On the left-hand side here, soybeans emerging. This is courtesy of Ohio State Extension. And then on the right-hand side here, what many farmers have seen across the region, and this is a courtesy of Hans Schmidt over in Indiana, ponding on fields, very wet conditions, keeping the planters out of the fields. and this is reflected in our corn and soybean progress. So if we look at corn progress, and this is against the 5-year average, so that number in the bracket is how much ahead or behind you are of the 5-year average. Corn planted on the left, corn emerged on the right. Wherever you see darker reds or those warmer colors, that's where we're behind the 5-year average. So you look at Nebraska, 11% behind, over to Illinois, 14% behind. Our friends in Ohio, given the drier conditions relative to the rest of the region, 12% ahead. And then Minnesota, right on the average. Corn emerged. No surprise with what is planted. We have seen emergence ahead of the 5-year average in Wisconsin, Iowa, Kansas, over into Illinois or Indiana and Ohio, and then behind where we've seen wetter conditions and delayed planting and field work as well. Looking at the similar story for soybeans, planted on the left, emerged on the right. Behind in the upper Midwest, Dakotas, Nebraska, Minnesota, and then we see a shift in the eastern part of the region, ahead of the average, Missouri as well. Emerged, we're all ahead in the emerged category besides the Dakotas, which are not planted. So a good signal to see on the emerged aspect of it, but still behind in the planting progress of corn and beans. Now, spring wheat progress is ahead of schedule where it's being planted, along with oats and sugar beet progress. So sugar beets, I don't know if I've ever seen these dark of greens on these progress maps, but plus 41 in North Dakota and plus 35 in Minnesota at 91%. So almost completely planted, 95% in Michigan as well. Okay, so now we're going to shift into snow, fire, rivers, and lakes, kind of give us an idea of snowpack, the potential for fire risk, our stream flows, river levels, and such. So this is the plot for the Missouri Basin Snow Water Equivalent. We call it SWE. This is the amount of liquid water that you would get out of a melted snowpack. So overall, you look at snow water equivalent percentages, ranging from within this polygon 100% to near 130% of normal, and this is to the southeast. So this is where we have above average snowpack. We have above average liquid equivalent within that snowpack, which is beneficial in terms of runoff and river levels as well. And then you go northwest into Montana, we're seeing 70% of normal or below. Higher elevations are holding on to snowpack. We've had some recent snowpack as well. And looking at the outlooks, we do see a signal for cooler outlooks across the upper northwestern part of the United States, which will hold off on advanced melting, but we will see melting over the next few weeks, feeding more moisture and liquid into the stream basins. A little grainy image here, but this is the Missouri River Basin snowpack as of May 13th. The left-hand portion is the total above Fort Peck, and then the right hand is the total from the reaches between Fort Peck and Garrison. And to orient you here, the blue shading is the 2023 to 2024 inches of snow water equivalent. The red line there is the average 1991 to 2020, and then the blue line is the minimum year. The green line or the blue line is the maximum. What you can see is that the curve is underneath the 1991 to 2020 average, but also along that minimum line. So we have seen, as I mentioned, an uptick in late season accumulation from snowpack from these more powerful systems that we've seen. As of the 13th, the reach above Fort Peck is 9.9 inches of snow water equivalent, and 81% of the annual peak remain. Normal peak is the 17th of April, and then the reach between Fort Peck and Garrison is 10.4 inches and 73% of peak remaining, so below average. Now, if we look at the Missouri River System storage, and this is the mainstream reservoir status as of the 14th, over the last 7 days, much of Montana has received anywhere from 2 to 5 inches of above average precipitation. And system storage is now at 54.3 million acre feet, still below the 1969 to 2020 average, which are these blue bars right here, which you can see. Here's the 2024 trend line right now, and the forecast is the dotted line. And then you can see 2023 much below where we are in 2024, and about 3 million acre feet more than last year at this time. So right now, the Gavin's Point release is currently at 24,500 cubic feet per second. And always, we mention this will be adjusted as needed for a downstream navigation targets. All right, another indicator of moisture and soil profiles moistening up, 28-day stream flows. And this is a reflection of United States Geological Survey stream gauges across the United States, looking at our region above normal to much above normal, wherever you see the blues across central and western portions of the Corn Belt. Then you swing over into the eastern Corn Belt, where we see the green colors, generally near normal. Looking at parts of the upper part of the threshold of our states, the UP of Michigan, northern Michigan, and parts of Minnesota and North Dakota trending below normal. And then you look at the real bullseye there, much below to low in Kansas. And these are similar conditions to what we saw last year. So improvement across much of the region for this time of year, and still seeing pretty dire straits in Kansas and getting into parts of southeastern Colorado. If we look at the significant wildland fire potential for May of 2024, really nothing across the region, given how wet conditions have been with the active storm track that we've been in. But if you look at June, we do see above normal potential across portions of Minnesota, Wisconsin, and the UP of Michigan. And looking at the climatological outlooks, we're really not certain as to why this exists. There must be something in the modeling that suggests the potential there. Maybe drying fuels and growing fuels has increased, but overall, kind of an anomaly when we're looking at the June 2024 plot. So tune in next month for an update on this. I'll kind of go through these pretty fast, but the Great Lakes are trending warmer than average in terms of surface temperatures. And again, this is a reflection of the lost winter and the very warm conditions that we've seen. And then we've had periods of near record lows on lake ice when there should have been an uptick or an increase in those lake ice levels. So if you look at the Great Lakes average ice cover, the historical average is in the red. You have all other years, basically the spaghetti on that plot. And then you have 2024, which is that black line, well below the average going back to 1973, and near record totals of lack of lake ice as well. Again, a reflection of just how warm we've been over the last several months. Great Lakes water levels, all Great Lakes have risen since the last monthly seminar, anywhere from 4 to 6 inches. And all lakes are below levels from a year ago. You look at Michigan and Huron and Erie, 1 to 4 inches below last year. By next month, we expect Lake Superior in Michigan and Ontario to rise 2 to 3 inches, and Lake Erie is expected to remain near normal. All right, getting into impacts and notable events. About 10 to 15 minutes left for questions. What has been the top headline for us besides delayed planting fieldwork, which goes hand in hand with the headline? Severe weather across the region so far. So since in April, almost 2,500 severe weather reports, hail, high wind, and tornadoes. That's 100 more than last April and 300 more than April 2022. Not to mention the tornadic activity that we've seen across the region, several rounds of large hail across the eastern part of the region. And then I've listed widespread events, April 16th through the 30th, and then events particularly the 6th to the 8th Midwest and Ohio Valley wind and tornadoes. Tornadoes in Ohio and Michigan of numbers that we haven't seen in several years. I'll go back and forth on this. This is the April storm reports, tornadoes, severe winds, and hail, and then this is the May to date. So this shows you how very active we've been, particularly the southern part of our region. Now, looking at just the year-to-date tornado, wind, and hail spread, very active across the region, from Nebraska all the way over Indiana, Ohio. Particularly concentration, southwestern Iowa, Nebraska, Missouri, but 790 tornadoes reported so far this year, almost 4,000 severe wind events, and 2,200 hail events. Now, if I just remove the hail and high wind, this gives you an idea of the tornado coverage across the region. Most of the states that have tornadoes or that have had tornadoes have broken their April records and their May records and potentially their spring records, given the extent of tornadic activity. And just a sub-note of that, 45 potential EF2 or greater tornadoes. So those are the significant tornadoes that do a lot of damage. So if you look at the top 5 events going back to 1950, this ranks as the second April count for tornadoes, 384. Only beaten by 2011, which was the super outbreak between April 25 through the 28th. So remarkable here that we've had a more active storm track, more thunderstorms, drought improvement, but also lots of severe weather. So these are just some pictures. Top left, Lincoln tornado, Minden, Iowa in the middle there, that was hit by 2 tornadoes, in fact. And then from National Weather Service, Wilmington of, I believe this was a Knoxville tornado in Ohio. Forgive me if I'm wrong there. I just took a collection of different news stories, and you can see severe weather, drought implications, rain implications on planting and field work, and then storm damage. So we're all over the board when it comes to where we are in the news. Just some impacts here. Ohio, warmest start to the year for Dayton and Youngstown. Second warmest for Toledo. And then we get into wet conditions. A new record for Toledo, almost 8 inches. Much drier conditions in May, as I mentioned, with the progress that they made in planting. 50 to 100% of normal for the bulk of the state. Kansas, the first fatality from a tornado in more than a decade at Westmoreland. And then Fredonia, 8.5 inches over 24 hours, the second highest total on record. Michigan, unusually warm winter threatens significant economic losses to peaches, grapes, and other fruits. And this extends into Illinois and other parts of the region. 12 tornadoes in Michigan on May 7th, the first EF2, and looking at the first tornado emergency ever issued for the state. 50 homes destroyed from the tornadic events. And then Illinois extension and producers are continuing to assess peach damage from January cold and late March freeze. So we've had both implications on a warm winter, but also cold snaps. Apples are not looking too bad so far. And as Trent Ford, my state climatologist colleague in Illinois, says, strawberries have been going gangbuster. Some other state impacts, I've harped on this, row crop planting generally ahead of the 5-year average in some states, but other states are lagging, and in some significantly, but lots of variability across the region. Pastures and rangeland are looking better than they have over the last few years given wetter conditions. I showed a picture of the microburst damage from Beloit, Wisconsin, and also seeing drought ease. Winter and spring wheat looking great in South Dakota as a result of above average precipitation. I mentioned freeze damage. Early warmth, a push in phenology, small grain planting well ahead of average in northern states. I mentioned the cold snap along with warmth that has impacted stone fruit and grapes and other fruits in Michigan and Illinois. In April, there was some moderate to major flooding in the upper Ohio Valley River Basin, which impacted and restricted navigation, and then I also mentioned 202nd consecutive week of moderate drought somewhere in the state, our longest drought since 1954 to 1959. So real quickly through these next set of slides, these are the aurora from a polar orbiting satellite, and this just gives you an extent of that G5 geomagnetic storm and the aurora that we saw across the region. Here's another look looking straight down on the Arctic. Just gives you an idea of how widespread and how far poleward or equatorward that the aurora were able to get. Okay, so now we'll get into El Nino, La Nina, and implications on our monthly and seasonal outlooks. So the map on the left here shows within the Niño region, the part of the equatorial Pacific that we monitor for above or below average sea surface temperature anomalies. This gives us an idea of the strength and the phase of El Nino southern oscillation, which El Nino warm phase, La Nina the cold phase. We're looking at a transition to ENSO neutral conditions imminently. And what ENSO neutral is, it's right in between El Nino and La Nina, so near normal sea surface temperatures. The warmth that we've seen in the sea surface temperatures through the strong El Nino in summer or in winter is starting to diminish, and we're seeing cooler temperatures prevail. And we're also seeing some semblance of the atmosphere decoupling or not responding to the oceanic waters. And this is important for the phase of El Nino or La Nina and moving into ENSO neutral conditions. So a transition to La Nina is expected in the July through September timeframe, 69%, with 50-50 chances of the La Nina occurring slightly earlier in the June through August timeframe, and this will continue through the Northern Hemisphere winter. So I won't bog you down with the plot here, but what I wanted to show is this, the transition of these colder waters in the Niño 3.4 region, which is showing a degradation in El Nino conditions and a shift towards ENSO neutral conditions. So as I mentioned, imminently we should be in an ENSO neutral. When we look at the percent chance, which is the vertical axis here, wherever you see that gray bar, that's that ENSO neutral phase. Wherever you see the blue bar, that's that La Nina phase. So as we amp up into summertime, we see higher probabilities of the La Nina reoccurring. So July, August, September, 69%, and then very high probabilities of it remaining through fall and into winter of 2025. All right, moving into the final set of slides here. This is the 7-day cumulative precipitation forecast. This gives you a summation of what the models are showing us, the expectation for rainfall across the region. Looking like a particularly wet pattern. This is in day 4, 5, and 6. So towards the tail end of the QPF or the precipitation forecast. So we'll have to see how the models continue to evolve. But generally through the central to eastern Corn Belt, the potential there for an inch plus, 2 inches where you see those more magenta colors. But this does suggest a more active storm track persisting across the region. Now, if we look at our short-term outlooks, there's a 6 to 10 and 8 to 14-day outlook. What we're seeing on the temperature side on the left, precipitation side on the right. Wherever you see those warmer colors, that's where we have a higher confidence that we're going to see above average warmth. Same side on the blue. What we're seeing across the region, and this is May 23rd through the 29th, slightly elevated cold signal for central Corn Belt west, and then warmer conditions to near normal Corn Belt east. But we are seeing a bullseye for leaning above elevated chances of wetter conditions across much of the region, particularly eastern Nebraska all the way over to Ohio and down into Missouri and Kentucky. Now, we have some experimental products that we use that kind of give us an idea of risks of heavy precipitation and high winds. We see this across much of the region from the 23rd to the 25th, and this is reflected in the QPF, but also a slight chance for windier conditions in Nebraska and Kansas. Initial June outlooks that were issued this morning, equal chances across much of the region, which is a climatological coin flip, 33% chance of above, below, or near average. But we do see an elevated wet signal from generally South Dakota and Nebraska swinging through much of the eastern Corn Belt. So if this holds true, we are seeing some semblance of a wetter signal. And again, we're getting into the wettest time of the year. So when you're seeing elevated signals for wetter conditions, this could be, wet conditions. Finally, June, July, and August, equal chances across the Dakotas and into Minnesota, but generally a warm signal across the region. And again, this is meteorological summer. We're not seeing a clear signal on the precipitation side. Some semblance of wetter eastern Corn Belt, drier western, but equal chances in the middle. Why the temperature outlook makes sense is that in years where we've seen a rapid shift from El Nino to La Nina, peer-reviewed journal articles do suggest a warmer signal for much of the region. Finally, an actual product that we can use when we look at the outlooks, this is the percent change in the possibility for rangeland production, so grass production in the high plains. So the seasonal scenario is if precipitation between now and August 31st is below normal, which we see in those outlooks, we estimate that the grassland production in your area, and this is pounds per acre of peak biomass, will be within this color bar. So wherever you see this color bar, that's where you're seeing below average yields, for lack of a better word. And this is a great product through the University of Nebraska-Lincoln. Finally, seasonal drought outlook. We do see drought improvement and removal, where you see those cream colors into that green color. And then drought persists in Kansas and then parts of Montana as well, but generally drought-free across the region. Short-term outlooks showing high probabilities of warmer temperatures, cooler central western Corn Belt. Seasonal temperature outlooks, not clear-cut across western portions of the region, but we are seeing the potential for warmer and wetter, warmer across the region, but wetter east. Drought conditions region-wide look to improve in the short term, but we have to hold out for summertime in terms of those longer-term precipitation deficits and longer-term hydrological impacts that can reemerge if we do get warm and dry. And so neutral conditions imminent with a high probability of La Nina in summertime. Analog years show summer conditions are typically warmer, but not a clear signal on precipitation. We've had wetter summers, we've had drier summers. Mesoscale, or what we call smaller scale thunderstorm-driven weather patterns, are hard to pin down compared to La Nina or El Nino impacts, particularly in summertime. There's a low correlation between the La Nina, El Nino climate driver and the smaller scale thunderstorm behavior. We do see a higher correlation in winter. With that, all the information from previous recordings and all of the different products that we use and that we have active. Finally, if you have questions, here are all our contact information, and I will turn it back over to Doug.
Thanks, Justin. Very good, and some accolades from the crowd. Hey, could you back up to the seasonal outlook? I think June, July, August. Yeah, that's it. So one of your comments was that wasn't a clear cut in the western part of the region, and I think we should just say north central part, northwest maybe, because the west the west definitely has a warm signal. Okay.
Yes, that was an editing error on my part.
Well, yeah. So just to pull this sort of all together, and Dennis, you can help me out, and obviously Justin. This is the summer outlook as it stands today. This will be updated on June 20th, as Justin said, by Aaron Wilson and the Climate Prediction Center when that comes out. We hope you tune in. Right now, the outlook is, the confidence in the outlook is that pretty strongly, the probabilities are pretty strong in that the Four Corners and places, let's say, for the most part, west of the Missouri, western high plains, are going to be warmer than normal. It also shows that there is some confidence in a signal for drier than normal conditions across that same basic area of our sort of western reaches. This shows that we could have above normal temperatures, more evapotranspiration across almost the entire region. We're not sure about the very north and middle, if you will, where it says equal chances in terms of temperature. But all around there's a leaning towards warm, which means, again, more evaporation and such. Precipitation chances for most of the region, the north central part of the U.S., except for the west, are also equal chances. So people have.
Yeah, Doug,
go ahead, Dennis.
Let me throw one more piece onto this too.
Yeah.
The one thing that the temperature outlooks don't do, unfortunately, is they don't separate high temperature versus low temperature, because a trend we have seen throughout most of the seasons, but particularly the summer, is warmer minimum temperatures. So it's a pretty easy trend to say we're likely going to have a warmer than average summer based on when you average the high and low, because we're getting more warmer low temperatures. The bigger issue overall is if we have warmer high temperatures, and we can't necessarily tease that out of this specifically.
And Dennis, later in the summer, if I'm wrong, or Justin, really high, if you will, low temperatures can cut back in yield in some crops. Is that correct?
Yes.
Low temperatures. Oh, sorry. Go, Justin.
No, go ahead.
Low temperatures can. High temperatures are a bigger issue.
Okay.
A more immediate issue.
And you think of last year in August, we had 2 heat waves across the region, one with very high dew points in the 70s, approaching upper 70s, which kind of protected from those warmer temperatures. But then we had very low dew points, very low relative humidities in concert with very warm conditions during the second heat wave, and that's where we got into some problems.
Okay. The other point I wanted to make was that with wetter than normal conditions that we've seen in most of the area, we're going to have the ability to, if you will, regenerate some of that moisture in terms of localized thunderstorms and all that kind of stuff. So there's moisture in the area. That's good. We're not going into summer dry. It's really good, actually. That'll help with potentially, like I said, regeneration of local moisture as we get away from pulling moisture off the Gulf, which happens as we get into July and August as well. Any other comments on the outlook, Dennis or Justin, that you want to make broadly?
There's some semblance of the El Nino signal still being ingested by the outlooks. We'll start to filter that out as we update the seasonal climate outlooks, but there is a lag from El Nino waning into ENSO neutral. So there could be some flavor of that in the outlooks right now.
And I would bet if you showed July, August, September, they would start to base more on La Nina, and definitely as we get into the fall, base more on La Nina.
Yes.
A little bit. So La Nina, what we'll see in the outlooks as we go forward, and again, tune in as we go down the road here, as we'll see the opposite of El Nino, what we saw for El Nino. What we saw for El Nino was the likelihood of warmer conditions to the north, warmer than normal conditions to the north, and at least equal chances to below normal as you head down to the south or Gulf Coast or near normal, whatever these days. And wetter than normal conditions into the northwest, maybe carrying all the way to the wetter conditions for La Nina, all the way to the Great Lakes in some years. That's a La Nina winter outlook. So anyway, more on that as we go along. I guess we should go to the questions real quick, and let me go through those. So how deep is topsoil mean? So Justin showed a map earlier on saying topsoil is this deep, and he said subsoil moisture, well, he didn't say, subsoil moisture is a different. Can you tell us the difference between topsoil and subsoil? Depths.
So subsoil, yeah, I don't know the particular depth that USDA uses. Dennis might know, but subsoil, of course, is deeper down. Topsoil, the first 2 to 4 inches.
Went straight to the mouth. NAS defines topsoil as the top 6 inches, and then I assume everything from there is subsurface. And I included the link to it in the answer to the question.
Yeah. And then there was something on it's the second or third slide showing an anomaly in North Dakota. You might zoom back to one of your earlier, it's not the second or third, it was beyond that, but it was one of your earlier maps. Maybe 30 days. I don't know which one. Could be any of those. But anyway,
yeah. So when you
related to precip or temperature, what causes that distinct anomaly in the focused area, and it really depends.
Right, you can have a station that's having a wet or a dry bias, a warm and a cold bias. That these anomalies pop up, or you could have a concentrated. There is some interpolation that goes into these maps. There are different products that show point-wise indicators that kind of get away from interpolation error. But yeah, there are all kinds of features and relics that can form because of different things in the observation systems.
And sometimes the observations are just that way too. It's just the fact.
Right, sure.
Yeah. They totally miss out on, let's talk about southwest North Dakota has been pretty dry as opposed to areas around it, right?
Yes.
And especially in the plains, station density is not as high as you go further east.
Yet.
So you are trying to contour larger areas based on a smaller number of stations. So contouring, especially precipitation, is a real headache out in this area.
Especially as we get into the warm season. And then the other question was, what's this next 60 to 90 day precip and temperatures look like? We've gone through that, I think. Is the severe weather related to the above average temperatures in April? Question. And then the person remarks about saying to themselves that April days being too warm, and wondering if the cold fronts are probably going to, when they come through, are going to cause some issues. And I wrote out sort of a long thing there, but the fact that we did have an El Nino sort of still impacting us allowed some of those storm systems to come through the southern part of the U.S., and thus that helps bring up Gulf moisture. So we are setting up ourselves for the potential for more severe weather. So yes, to some degree, El Nino had a little bit of part of that, but also the warmer than normal temperatures throughout the winter and spring. Anything you want to add to that in terms of above normal temperatures in April and severe weather, anyone?
Sure. So you look at the El Nino configuration of the subtropical jet, which basically is flat over the the Sunbelt states and the Gulf Coast. As the solar angle increases, as we see more daylight, those features start to move further poleward, and that's where we've seen that Gulf moisture being able to, along with warmer temperatures, infiltrate into the upper Midwest, and that's where we've seen that more active storm track continue over several events.
All right, I'm going to say Dennis should answer this question. And when will Western Kansas get out of the drought? And
what?
Well, he just say it's been in drought for 3 years, so he's just wondering.
Right, and I did go back and look because I was curious, because I thought Kansas had been cleared, and earlier this year there was a decent amount of clearing or easing of some of the drought, though not complete elimination, depending on where you were in Western Kansas. We'd love to know the exact answer to that. Western Kansas is kind of an oddity amidst everything else that Justin talked about. Much of the plains last year actually had a pretty good year compared to the Midwest, but Western Kansas still had some problems even despite that. So we should be seeing some improvement on that, but we can't say specifically when that would clear up.
It's a tough one, as I said there, and we were hoping that oftentimes during El Nino years, you get that moisture pulled up from the Gulf and it does impact western Kansas. And I think it's luck of the draw in this case. I hate to say it that way, but bad luck in the case of this. PDO status and possible influence. Oh boy. Ooh. Yes. Justin, I know you look at this stuff.
I have an article right here, but I haven't even read it, so I'm ignorant on this right now.
Me too.
There were some articles a couple decades ago that talked about connections between the PDO, which the PDO is Pacific Decadal Oscillation, which is a shift in the North Pacific, and what happens with El Nino, La Nina, and how they fit together. And I can't remember the phases. A couple of the different phases worked in concert to kind of exacerbate things, and a couple of the phases worked against each other. Yeah, go ahead.
So the cold phase of the PDO seemed to amplify effects that we saw in 2012 and 2013, the last widespread drought that we had across the region. So I think that might be the flavor of the question that we're getting.
Sure. The more direct relationships with the PDO are more along the West Coast. There are some very strong influences right along the West Coast. Like El Nino, La Nina, we are somewhat displaced from the main center of those changes. So it's not like PDO is this phase, here's exactly what's going to happen. It's maybe influencing a bit.
Yeah, and it's really the peripheries of the north and the south parts of the lower part of the CONUS in terms of the greatest impacts often for various reasons. You know, I live in Kansas City, Missouri, and it doesn't matter if it's El Nino or La Nina, we tend to be equal chances no matter what between those two, no matter if it's El Nino or La Nina. So I hate to say it's 50-50 because it's not quite, but it's tough in the middle of the country to attribute to a particular climate signal like that, a single one. The other thing we ought to mention, by the way, is the warmth in the Atlantic is off the charts in terms of temperature, warm temperature, and we're talking 3 and 4 degrees, 5 degrees in some places further to the east. What that means, I don't know. Did you show anything on that, Justin, by chance? You did.
I did not, but
yeah.
A shift to La Nina with those warmer waters could give us a very active tropical season.
Very active tropical season, and the fact that you have warmer water means probably more moisture in the air available if it can get up here to wring out, if you will. Yeah, and we might talk about that more in June. Dennis, let's not forget to tell Aaron to say something because we'll have the official report from NOAA by then. Others have already said it's going to be a very active season. What that means for us in the Midwest is quite variable. Nothing for the western part of the north central part of the area, but as you get closer to Kentucky and Ohio, it could mean more things happening.
Well, and it's maybe not directly tropically related, but can we get some remnant tropical systems that do come up and catch parts of the eastern part of the Corn Belt?
Yeah. Is there a link between warm sea surface temperatures north of Hawaii and Midwest temperatures? This sounds like an Art Douglas question from back in the day.
Yeah, yeah.
So there, I'm sure there is a link, but it's a chaotic system and we don't know the answer to that. So someone might have an answer. Do you, Dennis, do you want to say anything about that? This also relates to PDO. It also relates to, obviously, to sea surface temperatures everywhere across the Pacific, not just north of Hawaii.
Yeah, nothing else to add on my part.
Okay. Oh, a very basic question. What is a tornado emergency?
I don't know what the exact definition of it is, but it's when an observed tornado or even a radar indicated tornado is moving towards a populated region, like a city, small town, large city, and the impacts could be catastrophic if a tornado were to go through that particular part of a given region.
So it's almost like a level above, and anybody from the Weather Service, please, go type in your answer here. It goes on above and beyond a tornado warning in terms of the language that they use in terms of getting people to shelter in place.
Yes.
Or
think of a tornado watch and then a PDS, a particularly dangerous situation tornado watch, a much higher threshold on the language that is being used to protect life and property.
Any information to share on how this summer's weather conditions may impact the spread or severity, oh boy, of influenza A, H5N1 in cattle? I believe is that the bird flu? Or
yes,
something,
avian
or something
influenza.
else?
Yeah, high path. That's above my pay grade.
Nothing to add. There are folks who are doing work with this up at the Animal Disease Lab here in Ames. But it was mentioned at a meeting I was at the other day, but nothing weather or climate related. I could reach out to them and ask.
Yeah, Mark, let me suggest to Mark that he contact you via email. Your email's on the screen. Your USDA.gov email's there, and he can get back to you on that. Is that okay?
That's fine.
Oh, the last question about ocean linkages. Yeah, the question was, is there a link between warm sea surface temperatures north of Hawaii, and there's a lot of ocean north of Hawaii, by the way, and warm Midwest temperatures? So I'm assuming that means a lot of warmth up there. So basically, warm Central Pacific, North Central Pacific Ocean.
I mean, you have to take into account the phase of the Mad and Julian oscillation, in time of year. So it's a complex,
very
complex question that has a complex answer.
Quoting Namias, I love it. There's a linkage, but more so Gulf of Alaska in correlation to 700 heights in following seasons. Yep, I've read a lot of Namias in my day.
Excellent name dropping. I'm impressed.
Yeah, right.
I'm impressed. There's one more thing. Oh, one more thing I wanted to say real quick is, if you go back to the Outlook, this will be the last thing I talk about, unless you guys want to say something. Yeah. So all the averages for this are based on the more or less last 30 years, 1991 to 2020. If we went back to the beginning of the last century, 1900, and say we took 1900 to 2000 and did 100-year, everything would be warm. I want to make the case, and everything would show up as warm. There'd be no equal chances on here. We're trending warm, folks. And these are based on 30-year averages, what you're looking at on the screen right now. So when we say above normal, it's not a hard forecast to say above normal based on the last century. We're saying above normal based on the last 30 years, which has been already warmer. All right. So just kind of remember these things as we go through. Most of the climatologies we present are based on the last 30 years. Anyway, I just wanted to make that remark, and I know Justin will be pleased that I did. So anything else, Justin or Dennis, you would like to say at this time?
Nope. Great set of questions and great set of answers.
Yep. Thank you all, and we'll conclude now and see you hopefully next month on June 20th at 1 p.m. Central Time. Have a good day.